Welcome to Learning Unit 1. Think of this as your critical security briefing. To protect our product, you have to know its journey through this plant, every single step of the way. We're going to walk that path together, because understanding the flow, well, that's your first line of defense.
Okay, so here's our game plan. We'll start with the big picture, then we're going to track the gold from a raw piece of rock to a fine powder. After that, we'll dive into the chemistry, how it's dissolved and then captured. Then we'll see how it's recovered and finally smelted into a solid gold bar. And we'll wrap it all up by spotlighting the absolute highest risk areas you need to have locked down.
All right, let's dive in. Your number one mission as a security officer is to know this process inside and out. And why is that? It's simple, really. Once you can map out the entire flow in your head, you can start to see where the weaknesses are. You can anticipate where threats are most likely to pop up.
Now, this diagram here, it takes a massive, complex industrial operation and boils it down to a single map. This is our bird's eye view. Just follow the path, from the raw ore at the top, through every stage of processing, all the way down to the final, incredibly valuable product at the bottom. This is the journey we're about to take.
Look, this is the core principle, the absolute foundation of your entire role. Every patrol you do, every camera you monitor, every lock you check, it's all useless if you don't understand what you're protecting at each specific stage. This knowledge is what turns security from just reacting to problems to actually getting ahead of them.
All right, Section 2, from rock to powder. Let's get into how this whole thing starts. We're at the very beginning, the most physical part of the process, where these huge gold-bearing rocks get broken down into something that looks like fine dust.
Everything kicks off right here, at the stockpiles. This is where trucks dump the raw ore straight from the mine. The easiest way to think about it is like a giant pantry for the plant. It holds all the raw ingredients before they even get close to the production line.
Now, here's what's so important to get. Even at this raw stage, the product is valuable. These aren't just any old rocks. They're gold-bearing ore. Illegal miners know this, and you better believe they target these stockpiles. Your job is constant, vigilant monitoring and super strict access control. You can't let this raw material just walk off the site.
So from the stockpile, the ore gets fed into the crusher. And this is just, it's brute force on a massive scale. The jaw crusher does exactly what it sounds like. It literally chews up these enormous rocks and spits out much smaller, more manageable pieces. It's the first step in what the engineers call comminution, which is just a fancy word for making big things smaller.
After the crushing, the ore moves on to the mills for the final grind. Inside these giant rotating drums, that rock is pulverized into a fine slurry, like a really fine powder mixed with water. The whole reason for doing this is to create as much surface area as possible, so that every single microscopic particle of gold is exposed for the chemical process that's coming up next.
Okay, so we've physically broken the rock apart and freed up those tiny gold particles. Now we move into the chemical stage. This is where the real magic and the real chemistry happens. We're going to actually dissolve the gold right out of the rock and then capture it.
The heart of this stage is a process called Carbon-in-Leach, or CIL for short, and it's an incredibly efficient method. What you've got are two critical things happening at the exact same time in the very same tanks. A cyanide solution dissolves the gold, and at the same time, little pieces of activated carbon act like tiny magnets, capturing that dissolved gold. So let's break that down. First, the slurry we made flows into a series of big tanks. Then, the cyanide solution is added, which dissolves the gold. Next, the activated carbon goes in. Now here's the really clever part. The slurry is flowing one way, but the carbon is being pumped the opposite way. This counter-current flow is just brilliant engineering. It makes sure that the freshest, most active carbon meets the slurry with the last traces of gold, so you capture as much as humanly possible.
And here you can get a sense of the sheer scale of the seal circuit. Each one of these massive tanks is its own chemical reactor, just working away 24/7. From a security standpoint, you got to remember, the product now exists in two forms at once. It's dissolved in the liquid, and it's captured on the carbon. So we've successfully captured the gold onto these little pieces of carbon. Great. But how do we get it off the carbon and into a form we can actually use? Well, that brings us to the recovery stage.
It's really a two-step process. First up is elution. The loaded carbon gets washed with a hot, potent chemical solution that basically forces the gold to let go and dissolve back into the liquid. Second is electrowinning. We take that gold-rich solution and zap it with an electric current. This causes the pure gold to plate itself right onto these stainless steel plates called cathodes.
And this is what you get.
After electrowinning, the cathodes are rinsed off, and you're left with this thick, muddy sludge. Don't let the looks fool you. I know it just looks like mud, but this stuff is an incredibly high-concentration gold product. The value per kilo has just gone through the roof, and so has the security risk.
Okay, let's move to the final and, frankly, the most critical transformation. We are now entering the highest risk area of the entire plant, where that muddy sludge gets turned into the final product that everybody recognizes: solid gold bars.
To make that transformation happen, you need some serious heat. The furnace in the smelt house gets up to 1200 degrees Celsius. This is not just a workshop, it's a full-on industrial forge, and the security around it has to match that intensity.
And here it is, the final transformation, side by side. The input on the left, the output on the right. That unassuming sludge is melted down, the impurities are skimmed off, and it's poured into these molds, creating what are called doré bullion bars. This is the critical moment. The product is now in its most concentrated, most valuable, and yep, its most portable form.
Seriously, let this sink in. Of all the acres of machinery, all the miles of fence line, this one room is your #1 security priority. Period. This is where the result of the entire massive process is kept. The value is immense, and the security protocols here have to be absolutely airtight.
Okay, so we've walked the entire flow. Now let's bring it all together into a practical, actionable checklist. These are the zones where your attention needs to be the sharpest, 24/7.
So here's your security leaderboard. At number 1, no surprise, the gold room and smelt house. This is all about absolute, uncompromising access control. But right below that, you've got areas like gravity concentration, even the mill circuit, because high-purity gold can get trapped and accumulate in unexpected places. The CIL circuit requires you to watch personnel who have access to that gold-loaded carbon. And finally, don't ever forget about the beginning. The stockpiles are still a prime target. You see the trend here, right? As the gold gets more concentrated, the risk just skyrockets.
So I'll leave you with this question. You now have the map of the physical process. But security isn't just about outside threats, is it? Look at this flow again from start to finish and really ask yourself, where does an insider, someone with knowledge, with access, with a badge, pose the greatest danger? Because understanding that, well, that's the next level of securing the product.